Okay. Hello everyone. Today we are going to cover the Cosmos DB, and this is part of AZ-204 certification. And today is the fourth day which we are going to cover this Cosmos DB. Till now we have covered web app, logic app, function app, and blob storage. And this is the fifth module which we'll be going to cover. And who am I? Myself, Shadab Hasan. I'm Microsoft certified trainer and Microsoft certified Azure architect, having 14 years of experience with Azure.NET and Vista. So these are the following links which you can refer anytime. You can reach out to me for any doubt. So coming to what is Cosmos DB and why it is popular. So basically, Azure Cosmos DB is Microsoft globally distributed multi-model database, you can say. So this is the completely provided by Microsoft, which is like you can say this is a multi-model database, you can say. Okay, so what do you mean by multi-model? Multi-model means you can have other as application like other NoSQL database into the Cosmos DB, and which you can use as a wrapper. Like Cosmos DB has created a wrapper on top of that, so which you can utilize inside the Cosmos DB, and you can use those as well. So you can say that Cosmos DB is Microsoft globally distributed multi-model database, and this actually enables you for elasticity, independent scaling, and so many number of features which the Cosmos DB provides. So we'll be covering in the following slides. So multi-model database means like Cosmos DB gives you a feature like storing SQL API, MongoDB, Cassandra, Gremlin, and Table API. So these are the 5 flavors which the Cosmos DB provides you. And coming to that, so let's discuss about the why NoSQL has got popular and what is the difference between RD, BMS, and NoSQL database. Okay, let's suppose that I'll ask you to design a Facebook page which shows you the friends of friends and then what level of friends you have within your Facebook profile. Or if you talk about the LinkedIn, so you have the friends of friends of the friends. So it's showing the hierarchy. So how you can manage? If I'll ask you to create a table, so you will be writing like you will be creating a normalization, and you will be creating multiple table, and then you will be creating a relationship between that, and then you will end up of writing a multiple joins in that. Okay, so you will be creating multiple joins to get the data from your normal RDBMS SQL database. What NoSQL provides, like it doesn't have the normalized data. Okay, and it can have redundant data, duplicate data. Okay, so those are there. So like one file which is related to me, like myself is Shadab, and it's if you are storing a JSON file related to me, it will store whole data about me in the one JSON file. So you can just read and just display in your application. So that's the benefit which we get from the NoSQL database. Okay. So here you don't have any fixed schema. Okay, so you can just go ahead and anytime change the schema. You want to add another field and anything which you want to change anytime. So it's very easy to change here in the NoSQL database. Okay, so it's just a flat JSON format which is getting stored. Okay, so if we talk about like a scaling thing, okay, so what happens when you have data? Okay, so let's suppose you have the data 1, 2, 3, and so on. You have like some lakhs of data. Okay, so what you are doing? Okay, so you don't want to store all these in one table. Okay, so what you will do? You just divide this data. Okay, chunk this and store in the another partition. Okay, so what you will do, like you create one one data to second partition key, third partition key, like that you change. Okay, and here you just relate, this is like row key and your partition partition. Okay, and this again will have your partition key 2. Similarly, partition key 3 will be created. Okay, so here you are doing like sharing the data, like you are storing in the multiple like you will be doing a horizontal scaling. Okay, so generally if you have your SQL in on premises, what you will do, you can't do this, you can't create a same replica, you can't uh, um, divide your data. Okay, so you can't do like 10,000 records I'll store in this server, 10,000 records I'll store in other servers. That's not possible. So when you exhaust with your RAM, when you exhaust your hard disk, what you will do, you will just ask your infra team to just increase the capacity, either to add hard disk, either to add RAM, or any other sort of hardware. Okay, so, but what the NoSQL gives, actually it divides your data into the horizontal scaling, which is a scale out. So you will be creating a replica, like you will be storing a row key and the partition key. Again, you relate those partition key with the other partition key and you go ahead with those things. So that's what you achieve with the NoSQL database. Okay, so here horizontal scaling is very much possible. Okay, so again you have the MongoDB, that is very popular. Again you have Cassandra, that is a big data storage, and you have DynamoDB. Okay, DocumentDB, all those things you have. DocumentDB is completely Microsoft provided data. Okay, so if you take another example, okay, you have some gaming application. Okay, let's suppose that you have a gaming application. Okay, and you have created something under MongoDB. So let's suppose what happens. So you have the multiple regions. Okay, like one person is accessing from another region and this person is accessing from another region. Okay, now this core data is going to access your MongoDB. Okay, so that if you store this MongoDB in on-prem, okay, on-prem, what is happening? Okay, this sometime it's getting updated here, like some gaming application. Okay, this is the, like I can say, gaming application. Okay, so you just one region is using and writing here, another person is trying to access from here. So maybe like you have secured some points in the game, like you have 1,000 points. Okay, but if that is not replicated across the region, this data, then one person is seeing here the 10,000 point he is redeeming, again another person is going and he will be seeing the another 1,000 points. So if I log in from one region, again I go to another region and log in, again I can get this. So this should be like a scalable. Okay, first thing, it should be scalable. Another thing, it should be geo-replicated. Okay, so first thing, you should scale this. And second thing, it should be geo-replication, should be there. So that whenever the amount point is getting updated in one place, it should be replicated in the other place as well. So those features we will be getting here in the Cosmos DB. So just I told you that under the Cosmos DB, you get a SQL, MongoDB, Table API, Gremlin, etcd, and Cassandra. So these are the like Cosmos DB has created a wrapper on all those APIs, and you can host their application in the Azure cloud. Okay, so you are creating something Cassandra database and table API, MongoDB, and those you just come lift and shift in the Cosmos DB, and you just create USCale, multi-region read write you can do. So all those features which Cosmos can provide you. So you bring your data from the Cassandra and store in the Cosmos DB. So that's what we are getting it here. Okay. So additionally, like Cosmos DB provides a solution for the big data application, okay, by providing the high volume, velocity, and variety of the data. Okay, so you can store multiple kind of variety of data. HD inside also you can that's a Azure product which you can use for analytics. Okay, so all those features, once you come to the Azure, you can use those data in different format. Okay, and you have the variety of application which can be consumed those things. Okay, and that you will achieve globally. What feature here you get? These are the feature which either you choose any of these, you get these features like global replication. Okay. With consistency level, low latency, elastic scalable. So all these features which you get with the Cosmos DB. And next is here it's saying the global replication. Okay, so your data wherever is stored, like I'm just storing my data in India region, I can store another replication of data in the East US. So it's very easily possible with the Cosmos DB. Okay. Let's jump into the portal. I'll just show you how we can do. We have to create a first resource group. Today I'm creating a 4. Okay. Generally I prefer STUS. Okay, and create. So this is the resource group. So here you have Azure Cosmos DB. Okay, you can just go ahead and read those. This will be actually a very good description has been given here. Azure Cosmos DB is fully managed, globally distributed, horizontally scalable in a storage and throughput. Okay, multi-model database. Okay, so these are the very good description which you can just go through those. Okay, and I'll just go ahead and create here. B408 0811. If you see here it's giving me the core SQL. Okay, then you have the Azure Cosmos DB for MongoDB, Cassandra, Azure Table, and Gremlin. Okay, so Gremlin is again Graph API. Okay, so I was talking about, I have another slide which I want to just show you what Graph API is. So actually the Graph API, like if I talk about the relationship, that's what I was asking. So if I'll ask you what is the common things between Thomas and Robin. Okay, so both using a Windows laptop. Okay, if I'll ask what is the common between Thompson and Ben, so they'll play football. Okay, what is the common between Ben and Robin? Both using the Android application. So these you can maintain with the Graph API. If I'll ask you to store these in the SQL database, like you will be end up of writing multiple query and storing multiple database tables, all those things. So this is the one of the example of Graph API which you get. So you have the vertex and edges there. Okay, vertex denotes like person, place, and events, and then you have edges which denotes like, for example, a person might know another person. Okay, so what is the common similarity between I and you? Both are attending a common training. So this could be a similarity. Okay, so there could be different matches which you will be finding, and then you will be creating a graph. Okay, so this is the one of the example of Graph API. So here you can select anything whichever you want to store, and we'll select the region. Okay, this is like capacity mode. It's asking like you have in the web API, like you define your application, how much infrastructure you need. So here it's saying the provision throughput. So you can define your throughput, how much throughput you need. Another, this is the serverless, which is coming in the preview. So this is not recommended to use in production. It's still in the preview. Okay. So, but you can go ahead and do R&D. Okay. Because what the serverless means, if Cosmos DB coming in the serverless, whenever you need additional throughput, it will automatically increase and your gives the performance to your application. That's the serverless means. So let's go with the provisional throughput. Again, you have option for production and non-production. If you select production, say you are getting a redundancy, multi-region rights, availability zone options. Okay, so this is the only Cosmos DB which gives you the multi-region rights, multi-region read. So if you go with the SQL, like you want to multi-region read write, so you will end up with the issues. Okay, so you will always have some consistency issue or the data will be lost. So here, this is the only provided with the Cosmos DB. Okay. I can just go ahead and hit create. There is something which I want to show you. If you just Google, there is called CAP theorem. So what this CAP theorem is saying that consistency, availability. So if you talk about the consistency and availability, both cannot work together actually. Okay. If you try to manage the consistency, somewhere you lose the availability. And if you try to maintain the availability, somewhere you lose the consistency. So that's the impact consistency versus availability you have always. Okay. So this is the CAP theorem says. Okay. So this is really always contradicting. So you can't maintain everything together. Okay. So always there will be a differences will be there. Okay. Okay, till the time it's getting prepared. So here again, it's saying about the consistency. Okay. So once it's ready, I'll show you. So basically, Cosmos DB gives you to set the consistency level. Okay. Whenever you are trying to write in the multi-region, just we saw that we can replicate our data to the different region. So it asks you what consistency level you want to set. Okay. Generally, it will be in the mid always. And you can set to consistency level to a strong, okay, and otherwise evaluate. So what happens in a strong? So a strong means immediately your data will be replicated in the other environment and other region. So you will not have the latency of the data. Means data will be same as it is what you have in the primary region. Okay, so the same way data will be replicated immediately. See the consistency level. Strong means when write operation performed on the primary database, the write operation is replicated to the replica instance immediately. So this is what consistency level says. Okay. Any question till now, if you have, by the time it's getting prepared. This is the APIs which I was talking about, the MongoDB, like table API, Gremlin, that is the graph API. Again, you have Cassandra and the SQL. Okay. The SQL is like, you can say it's Microsoft, earlier it was called as Document DB, later on the Microsoft has changed to SQL API. Okay, so it's completely stored in JSON format, and you can write store procedure and triggers. All those are supported here. So this is completely Microsoft product, you can say. Others are different products, which is the wrapper, which we have created. Microsoft has created a wrapper, and that will be available to you. Other things like how to migrate. Okay, the question comes like how we can go ahead and migrate those data to the our Cosmos DB. Okay, so Microsoft provides a different kind of migration tool, like you have Cassandra Sail, Mongo Dump, and Mongo Export. So those are the tools which has been given by the Microsoft, which directly you can do lift and shift to your Cosmos DB. So you don't have to write your own code and define something like this data has to go there and those. Directly, you just create and use those tools and export those data and store in your database. Okay, so only prior to migration, you just need to include your request unit, like how much request unit will be accessed, so you can increase those RU, so request unit, so that your application will be easily imported, data will be imported. So these are the features which you get. It's taking so long. Anything which you want to add up in this slide still now? RDBMS, NoSQL, anything? Okay.
Sadap, hi Sadap.
Yeah.
Yeah, normally all these structured data we are using in the SQL and all this. Can we? Is
Correct.
there any possible to that is migrate the SQL to the node or sorry, that is MongoDB, or is there any possible? Because that
Uh,
is a unstructured data, I think.
Correct. This is unstructured data.
So
And
is there?
why do you want to import? So there is the way. See, always there'll be some purpose why you are using. I have one tutorial somewhere. Okay. Just I want to show this architecture. Okay, this is some API first SaaS business model architecture from Microsoft. Okay, so why you want to move your SQL to Cosmos DB? Is there any reason? Uh, is that the flat data, or is there any relationship established with that, or you have some complex structure in that? See, this is the Azure Kubernetes structure actually. Okay, so see, this is the application. Okay, which is using Cosmos SQL and storage. Okay, why you can't say that I completely want to move to Cosmos? Okay, what happens? Like there are some limitation with all the you can say services which is provided by Microsoft, and there will be benefits. Okay, what benefits you get with SQL that you will not get with the Cosmos DB? And there are some benefits which you get from the Cosmos will not get from the SQL database. Okay, so one application can have the SQL, also have the Cosmos DB with the application. Okay, so like if you want to consist of something relation database and you want to store something which you will not be able to manage in Cosmos, so you go with the SQL. Okay, but if you are feasible, like I was talking about how you will maintain the relationship between the friends of friends, and you want to maintain some graph or something like which is not like relational database. Okay, so then you move to the Cosmos. Okay, so there'll be you have to read the white page from the Microsoft, which provides you the what is good, what is bad with the Cosmos, and what is good and bad with the SQL. Okay,
Okay.
so like that you have to understand and define the architecture of your application.
Oh,
Okay.
oh.
Okay, so this is the resources provision. Uh, so you can see here, replication. Okay. So here I'm storing currently my data in East US. It's saying here. Okay. So I can enable like multi-region rights. If I enable, I can add multiple region here. Okay, I can select here Central India, and I just say okay. So there, this is the two replica data has been created. Okay, so this and this, whenever I try to write in this East US location, immediately my data will be replicated across the globe. Okay, so my data is stored also stored in Central India. So this is what you define here in the global replication. Okay, so what basis it's replicated? You can go here, default consistency, which I was showing you in this slide, default consistency level. Okay, so what is consistency level? If I say a strong, so means the two replica which I have created, it will be always be synced. So this is the data it's moving. So always you see here data is always synced. Okay, if I go with session, it will be some lagging of data will be there. Okay, and if I go for last one, so it's data is here and there. The data will be replicated for sure, but it will be lagging. Okay, some delay will be there in the consistency. Okay, so why I was talking availability and consistency always. Okay, so if I say I want a strong consistency, means somewhere I am challenging my availability. Okay, so because when it's getting replicated, that time my application may be slow or some lock will happen. Okay, because it's immediately moving the data towards the another zone. Okay, so that could be the possibility. Yeah. So it's always say that you should be in between of something and then you try to manage those things. Okay. So always it's difficult to make among everything like consistency, availability, latency, and throughput. If you say that I will be able to achieve everything within the one application, that's completely not possible. Okay, somewhere you have to take a midway. Okay. Uh, Another thing, like you can go and search for Cosmos DB. So here you can see that how the CPU request unit is getting calculated, okay, and how you can define those things. Request unit calculator. Okay, so here it's saying me what request unit I should configure for my application. Okay, like this, I have selected SQL core. Number of region, I am writing in one region. Okay, so if I want to enable multi-region read write, I should enable, and then what number of data you are using, 10 GB data. Okay, and what is the item size? Like item size means one file size it's talking about. Okay, so I can define here what the file size will be, and then read per second per region, create per second per region, upload per second per region, and delete. And finally, it's calculate and saying with the estimation cost here. and what is the RU request unit. It's showing me here. So these are the calculator available with the Cosmos DB, which gives you the pricing as well as the RU unit, which you can calculate. Also here you have the pricing tier, which says that what is the charges you have to pay for the single region write, multi-region write. So all those charges will be occurred. Okay, so coming back to the portal. Okay, so here it's giving me to add a container. Okay, so if I'll go in the next slide, it says the same thing. Structure, resource hierarchy. You have account, then you created a database. Inside the database, you will be creating a container, and then you will be storing all these data. So you'll be having item, a store procedure, trigger, user-defined function, and conflicts. So these all will be in hierarchy. It will be stored. Container will be called as something collection. So here is container. You can say add container. Okay, before container, it's saying me to add a database. Okay, so you can give your database name like products, and this is the scale. You will be defining RU. Okay, so it's from the 400 to 10 lakhs. So this much read write unit you can change. So based on that, your cost will change. Okay. So you'll be defining the container. Okay, this is the container you will be naming as container, like product, I'll keep container name, product, I'll keep database name. Here you will be defining the partition. Then basically your application will be stored inside the partition. Okay, so partition means one file will be having the partition and the other partition. So this will be created a partition for the particular key with the particular keyword. Any specific key which you can take, which will be stored in your database. Like I want to store my data based on the zip or based on product category. Okay, product category. Okay. So this will be a partition key. Based on this, my data will be like a scale. So this will be happening inside. It should be your like one column will be there, and then you can just create. So this will be created, and then you can store your data inside those. Okay, so this is the products, and then product, you have item. So item is your data. Okay, there is no data, so it's not showing me here. You can store a stores procedure, user-defined function, triggers. So this gives you similar flavor like your SQL server. Okay, you can create a store procedure. Store procedure will be not like a SQL store procedure. It will be written in the JavaScript. Okay, so that you can write here and you can store. Okay, so coming back to this slide. Okay, so this is the resource hierarchy, and then you have account. Okay, so account where you will be setting a database, and then inside the account you will be having database. Then you have collection or container. Okay, so you'll be storing a JSON format data, so which will be your document, and then you have a store procedure which you will be writing in the JavaScript format. Okay, then you can have a trigger like insert, replace, delete, those functions which you can achieve with the trigger. And then another, you have again user-defined functions. Again, you can write certain logic in the JavaScript, and you can use those inside your Cosmos DB. Again, this says that how you can define your container, and just now I've created a container with the some request unit. So based on that, you can define that how much request unit you need for your database. Okay, so like if you do more transactions, okay, so you have to define a more RU. Okay, So if you think like your application will have the more load and more requests are coming, then you have to increase your read unit for your container. Again, here it's saying the partitions. So just now I talked about the partitions, like how partition will happen based on some like column available. Like I have created a category. Okay, so based on the category, what happens? The partition will happen. Okay, so for one category there'll be one partition. For another category there'll be another kind of partition will be created in the system. Again, it's saying that the talking about the partition implementation, like this is the logical partition. Okay, so within the physical, so there'll be a logical partition within the physical partition. That's what happened. Okay, so this is the physical thing and this is the logical thing happens. So you define a partition key. So logical partition abstraction happens, and then behind the scene there'll be a physical partition, like your data will be stored in the different zone or different hard disk. So that happens inside the Azure. Again, here you have to, if you are using your application, okay, to achieve the from the code, you can manage all those things. You can store data from your application. Like if you have the .NET application and you want to store your data to the Cosmos DB, or you want to manage your data from your .NET code, you need to install this Microsoft Azure Cosmos package from the NuGet, and then you'll be able to achieve this code. So here it's a simple code which is trying to write. Let me show you one code. So that also you can go ahead and download from here. Okay. So this is the tutorial for the .NET console to manage data in the Cosmos DB. Okay. You can go ahead and download from the GitHub here. Okay. So I'll just show you what I have did. This is my Cosmos DB. Okay. I'll copy this path. Okay. Because this is my URI for the Cosmos DB. Okay. So I'll be putting it here. And then I need a key. So as you know, always we need this connection string or key to connect with our .NET application or any outside application which you want to do anything with my application, that you should have a connection key. Okay. And okay, what this program does actually, it's using my this endpoint and the primary key. Okay, and then it's trying to create this database, family database. It will create, and then inside the family database there will be a family container. Okay, and what it does, it will create a database, it will create a container. Okay, it will add item. What this will add, it will add a family database. Okay, so this is the Anderson's family, and then there'll be Wakefield family. Okay, there'll be this two family will be stored. You can see here in Anderson you have the child, and there'll be here two childs. Okay, inside the child again you have the name given, but here you see that there'll be only one child is there. Okay, so there'll be no proper data which you can say like, and there'll be data difference, there'll be column difference, and you don't have the particular data maintained here. So that will be created. And after adding the data, it will go and query the data, replace the family, and then delete the family and delete and clean the database. So this is what will happen. Okay, let me run this. Okay, so here we have the, it's starting the operation. Okay, created a database, created a container. Okay, so once I go here in my Cosmos DB, If I refresh and I go to Data Explorer, I can see here, this one I have created earlier. So this is the family database has been created, okay, from your code. But here I don't have any data as of now, okay. Let me run this again. So it's creating data for Anderson and then running the query, okay. So you can see here it inserted data and then doing a query of this data. So if I go here and refresh my family item, refresh, I get here two data. Okay. So this is stored in your JSON format. This is the JSON format which is stored. Okay, Anderson last name, parent, family name, children's address. Okay, and these are some metadata which is associated with this, which is maintaining those data. And if we go to this family, again, you have the parent, family, childs. Okay, so those are stored here. So this is how the data will be stored, okay, in your application. Now if I run, it will just delete this data and delete the container and the database. Okay, so this is what has been done. So this is the simple code which you can see here. And this is what's happening, like when the database exists, it creates a database, okay, referencing existing database and creating new database. Those are here. And again, you have the .NET codes. Managing Cosmos DB, okay. Querying document using the .NET code. So again, you have the link queue query. Okay, actually, if you see the code, what it does actually when we are querying the database, it's normal query like you do in the SQL. Okay, select a start from C, where last name is Anderson. So it's a simple query, link queue query, which will be executed on your Cosmos DB. So it's like simple like update query as well. So it's nothing difference between much difference between your SQL and this, but here you are maintaining the data in the JSON format. It will be the lightweight as well. Sometimes it less price as well, but you can't say it's always the price is less here. Okay, but when you go with the replication on all those things, so it might be the similar to the SQL or might be same or more. Okay, it's different, differs what kind of facility you are getting from the Cosmos DB. So based on that, it creates. Again, here we say that JavaScript and Azure Cosmos DB. Okay, so I already told that you can create your write the code in the JavaScript and you can save in the store procedure user defined function, and those things you can create it here. Again, it's saying a store procedure Cosmos DB JavaScript hosted on memory. Okay, so this is the sample store procedure has been shown that you can create a function. Okay, so it's just a simple function, get collection, create document. Okay, so these things are here. Oh, again, this is a simple thing which is the Cosmos is checking that it's true, will complete it, and then if it's false, then you roll back. So those you can do as well in the Cosmos DB.
Can we use transactions in this Cosmos DB, Sada?
Yeah, you can do that. You have to write you have to write a custom code for that, and you have to write like it shows that the you have to write a JavaScript function. Okay, so which will achieve this. Okay.
Inbuilt functions, inbuilt transaction, there is no provision, I think.
Yeah, nothing. Yeah, because it's a flat like document.
Yeah.
Okay, so just it's writes and commits.
Okay. Is there any data types in the Cosmos DB, like we
Nothing like
have
that.
AirCal, like that one?
No, nothing like that. You just see here that just now which I have created. There is nothing data type has been defined. You just store whatever you want to store in the Cosmos DB. Okay. So first I already told there is no a specific schema defined here. Okay. So you just everything you can store flat. Okay.
Okay. All the data type is string type only. There is
Yeah.
no floatl like that one.
Correct.
We don't have any. Yeah.
Correct. So the main challenge here is with the RDBMS and NoSQL is like RDBMS, you define a schema and you will not be able to easily modify once you create a relationship between multiple tables and you do multiple transaction with that, then it will be very challenging to modify the schema. But here, if you tomorrow, if you want to add another field in this, you can directly go ahead and start adding that. And it works on fly.
Okay.
Yeah, that concludes for today. Okay, and actually, I'll share this labs. Okay, this is the lab which you should be doing for the Cosmos DB. Okay, so this actually, I prefer to complete your labs for each topic because whenever you go for the examination, you will be having some of the questions from the lab scenario based questions. So make sure you go ahead and complete all those labs, whichever we are topic we are covering up. So here you just create a, go ahead and create SQL database, Cosmos database, storage resources, and later on they are using something import and validate data from the container. Okay, so this is what it is. Any
Can
question as of now?
can you
Yeah,
share
go ahead.
the recordings?
Yeah, of course. We have already uploaded the recordings in the YouTube channel, and
Okay. 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 Okay.
I sent mail yesterday. Hopefully, you guys
Yeah.
have
Yeah. Yeah.
received
Yeah.
and
Yeah.
rest
I
of
received
it.
that.
Yeah, so you can check on the YouTube. So
So that just one Narayan here, one quick question. So if we want to save any file type of data, means some of this Word document or text document, so will it be saved directly in custom DB or it will save somewhere and place the reference over here?
what kind of document? Can you
Any
elaborate?
text file or some
Means some kind of attachment you are talking about.
attachment. Yes, yes.
Yeah, so better that you can relate those in the storage account as we discussed yesterday. So if you have some media, some image or text file, better to store in the storage account, and then you can store that link, that path of the storage account here, and then you can relate it. Okay, so that you can do that. So this actually you just saw that in the application what we are doing here. We are just storing the data and we are displaying. While querying, if you have your storage account path in the database as well, you can extract those parts in your application. Like if you have the web application or any .NET application, you can just query those data. And once you get the path, you can display in your web application, like click here to download the files or anything which you can achieve.
Okay.
So that's possible. So you'll not be able to store your like file here, okay, because this is the data. So generally, yesterday also we discussed about when we were discussing about the storage. Like generally, what we do have, we always have some SQL table, okay, and then if we have any file which is which you want to download and showcase, so we can have store the link in the table as well. So similar thing here, you can do that.
We'll store the file over there and link will be over here.
Correct, correct. So that's will be done. You can see here the architecture which I have shown you. Is the similar kind of thing, I guess. So this is the architecture. Okay, so this is the AKS Azure Kubernetes service. We'll be talking in the next session on 14th when we'll discuss about the virtual machine Kubernetes and Dockers. All those we'll discuss there. So we'll talk about this one, but yeah. So if you talk about this application, this is going to the Cosmos DB. It's getting data from SQL as well, and then it's using the storage, Azure storage as well. So you will be having, when you define the architecture, you will be having multiple combination. You will not rely on one database or one thing in the Azure. Okay, you will be achieving multiple services inside the Azure. Correct. So whichever the cost effective and which suits to your application, you will be achieving those things.
We have multiple features and options. We can use that and scalable.
Correct, of course. So, but with Cosmos, you'll get like multi-region read write, which you don't get with other. But yeah, but you have to see that where it fits in your application. That matters actually.
Yeah. Oh, thank you.
Any other question, doubt? We are ahead of time. If any question is there, we will be taking it up. So hopefully you are clear with the concept of the Cosmos DB. I'll share this PPT with you guys, and the recording will be uploaded in the YouTube, so you can go through those. Sure. You also go through this coding thing, because sometimes this also comes in the exams basically. So sometimes they'll give this coding thing, and then they'll select, see what in the drop down you might have to select these things. So they'll give multiple things here, and what will come in the drop down. So that you have to see. So you should be familiar with the coding approach as well. Okay, so as I have shown you this code, you can download it and go through those. This code is available in the GitHub. Okay, so directly you can download and you can go through those.
Okay, sure.